Here we have a question. In this question, we have to find the equivalent resultant force Fr and show its direction of the resultant force and also find the couple moment at the point A. So first of all, in order to find the resultant force, we must know all the forces in x direction, after that all the forces in y direction, and after that we can add all the forces in x direction and equate them equal to the component of resultant force in x direction, and same for y. We can write it as component of resultant force in y direction. So with this help, we can find the magnitude of the resultant force, and in order to find the direction, we can use the value of tan theta, where tan theta is written as opposite side divided by adjacent side. Here we'll keep forces in y direction divided by forces in x direction and find the value of direction of the resultant force. And in order to find the couple moment, we will use the technique that the moment due to resultant force will be equal to summation of moment due to forces about point A. So with this help, we can also find the couple moment. So now let's begin. So as we discussed, there are two methods in order to calculate the moment. Let's see what we'll use. So here, as per the given data, we can see that F1 is a force which is acting in downward direction, which is 650 Newton, and it's making an angle 30 degree, which is angle theta, with positive y axis in counterclockwise direction. And force F2 is acting purely in y direction but in downward, which is 300 Newton, while the force of 500 Newton, which is F3, is acting at an angle 60 degree with positive x-axis in counterclockwise direction. And the moment M, which is acting at the point A, that is given to us, which is 1500 Newton meter. So let's begin. So as we discussed, first of all, let's find all the forces in x direction. So here there would be component of this force which is acting in x direction, and there would be component of force which is acting in x direction. So from here we can write F1 sine theta minus F3 cos theta 1 as the Frx. Now let's write the value of Fry. The value of Fry would be equal to minus F1 cos theta, it's acting in downward direction, minus F2, it's also acting in downward direction, and minus F3 sine theta 1, it's also acting in downward direction. So we have found the forces. Now let's find its magnitude using the Pythagoras theorem, where we can write the value of resultant force is equal to under root of square of x component of force and y component of force, and we'll add them and take the square root and find the value of Fr. Now, in order to find the value of theta, we'll use the y component and x component. As we discussed, we can write tan theta equal to Fry divided by Frx. So from here, we can take tan inverse on both the side and write the value of theta as tan inverse of Fry divided by Frx. We'll name it as equation number 4. Now, we have to determine the resultant component moment. For that, as we discussed, we can write the moment due to resultant is equal to the moment due to summation of moment due to all forces, or we can say the summation of moment due to its component. So from here we can write MRA equal to summation of M about A. So from here we can write F1 cos theta into L1. So the perpendicular component of this force which is acting in downward direction, that is F1 cos theta, and this distance is L1, and it's giving a counterclockwise moment, so we'll consider it as positive. Now let's come to M. The moment M is of 1500 Newton and it's also in counterclockwise direction, so we'll consider it as positive. Now let's come to force F3. So the downward force is acting is F3 sine theta 1, and it will give a clockwise moment, so we'll consider it as negative. So now let's substitute the values. So after substituting the values, we can find the value of Frx, that comes out to be 75 Newton. And the value of FRY, that comes out to be 1295.93 Newton, and it's in downward direction, while the FRX is in this direction. So from here we can draw that the FRX is in this direction and the value of FRY is in downward direction. So the value of resultant force will act in this direction somewhere. Now let's find the value of tan theta. This is the value of theta that we will calculate. So first of all, let's calculate the magnitude of the resultant force, which comes out to be 1.30 kilonewton, and the value of tan inverse, as we discussed, we can write the value of theta as 86.69 degree, and it's towards southeast. So now we are going to find the moment about point A, the resultant moment about point A. So as you substitute the values, we can find the value of FMRA, that comes out to be 1.02 kilonewton meter, and it's in counterclockwise direction because it comes out to be positive. And as we discussed, if the moment is positive, we'll consider it as counterclockwise. So from here, we have found the magnitude of resultant force, which is given to us, which is 1.30 kilonewton, and the direction of the resultant force, which is 86.7 degree in southeast direction, or we can say in clockwise direction from positive x-axis. And the moment about point A, the resultant moment about point A is 1.02 kilonewton meter in counterclockwise direction. Thank you.